Here I have a glow stick, and here I have a laser. Glow sticks can be used for Halloween costumes or for lighting up venues. Lasers can be used for pointing at slideshows or for precision manufacturing. So how can a rather intense light beam operate on the same principles as a child's toy? Lasers and glow sticks may serve different purposes, but the interior operation is very similar. To understand this similarity, we need to dive into the science behind the two. It all starts with stimulation.
Once the rock hits the water, we can see the waves are created from where the rock landed. In this case, the rock is a stimulus, and the waves are the response to that stimulation. Stimulation can be seen in other macroscopic instances, such as pulling on a tree branch after a snowy day, and the snow on the leaves falling onto your head. But stimulation is not only something that occurs at the macroscopic level, but it can also be seen at the microscopic level by observing light emission. There are two types of light emission, spontaneous and stimulated. Spontaneous emission is responsible for most of the light we see everywhere around us. Spontaneous light emission from a substance can be described by electron movement at the subatomic level. Essentially, when an atom is given an excitation, which can come in the form such as an electrical signal, heating of the particles, or any transfer energy, this electron can jump from its current state to a new state. These states or energy levels are temporary, and the electron will eventually lose this energy and fall to its original state. During this fall, the electron releases energy as a photon, which is a little particle of light. In simpler terms, a stimulus causes this emission of a photon. The release of this one photon is called spontaneous emission. Spontaneous emission leads to the definition of other types of light emission, stimulated emission. These two types of light emission are actually more related than you think. Stimulated emission is when an incoming photon is used to release an additional photon during the energy drop of an electron from a high energy state to its base state. We can visualize this stimulation in another way. Imagine a leaf with water resting on top of it. This water can be considered stored energy. Now a different droplet of water falls from above onto this leaf. As a result, all of the water on the leaf, in addition to the droplet from the branch above, falls from the leaf. Stimulated emission works in a very similar way. A photon at a specific frequency, otherwise known as the water droplet in the previous example, interacts with an excited atomic electron, the water on the leaf, and as a result causes two photons to be emitted from the electron, the collective water that'll fall from the leaf. Spontaneous emission is what starts the process of stimulated emission, triggering the photons to bash into electrons, which triggers more photons to be released, which bash into more electrons. This process is exponential. As one photon enters, two leave, sort of like a positive feedback loop. Stimulated emission is a way to control the emission of photons and make light do what we want, whether it is the chemiluminescent properties of a glow stick or the lens-concentrated photons that make a laser a laser. Both glow sticks and lasers use the same quantum process, but they produce very different light forms. Both glow sticks and lasers are related to light emission in different ways, but the way the emission is utilized allows for different applications. Glow sticks operate on a principle called chemiluminescence, which is a subset form of luminescence. Luminescence itself is a spontaneous emission that is not caused by heat. A luminescent substance will absorb energy from a source and release the energy in the form of photons.
For glow sticks, two chemicals are in separate containers within the same tube. When you crack the glow stick, the interior container is broken, allowing for the two chemicals to mix. In addition to the product of the two chemicals, a byproduct of CO2 is produced, which makes an exergonic reaction. An exergonic reaction is one where the energy is released in addition to the products. This energy can be absorbed by the dye in the glow stick and create spontaneous emission, which then leads to stimulated emission.
The final result is the colored dyes glowing their characteristic neon color that lasts several hours. The chemical reaction will continue until all the reactants are used up.
Lasers produce light in very different ways than glow sticks.
Most lasers produce light by passing electric current through a gain medium, a material that can amplify light via stimulated emission. The energy from the electric current is absorbed in the gain medium, which triggers spontaneous and stimulated emission inside of it. This stimulated emission produces a beam of photons, and the beam is passed off a highly reflective mirror and a partially reflective mirror, then concentrated by lenses to produce the resulting laser beam. Lasers and glow sticks work off the same principle and both produce light via stimulated emission. These two different items show the vast usefulness that stimulated emission has, whether it's for pointing at figures on a board with a laser pointer, or lighting up a room with glow sticks, or even using laser therapy to treat cancer. Stimulated emission has many applications in several fields, and you have probably seen stimulated emission before without even knowing it.